Hello students, this is Miss Dalton and this is the beginning of Unit 6, and in this first video we will just introduce probability. Your learning target is by the end of this video you should understand the difference between theoretical and experimental probability and be able to calculate probability. So here are some vocabulary words that you need to be able to identify. Probability. Probability is just quantifying uncertainty. It is assigning a number to how likely something is to occur. If it is impossible, if the probability of something happening is impossible, then that will be a probability of 0. If it is a certain probability, then that's going to be a probability of 1. So all probability is going to be on a range from 0 to 1. Meaning the closer it is to 0, the more unlikely it is to happen. The closer it is to 1, the more likely it is to happen. We can also put that as percent. 0 would just be 0%, and then 1 would be up to 100%. And so same thing applies. The closer it is to 0%, the more unlikely it's going to happen. Closer it is to 100%, the more likely. A few other vocabulary words. Random sample. A random sample is a sample that is drawn from a population where each member is equally likely to be chosen. We will also use this vocabulary word, fair coin. That just means it is a coin which is equally likely to land on head or tails. All right, if I was in class, we would do this at your table group. You would flip a coin 20 times, and each time you flip it, you would record whether or not it lands on heads or tails. And so I've done this myself. So each time I flipped the coin, I recorded whether or not it was heads or tails, and I've created this table. So now what we're going to do is we're going to add up the total number of heads. So there was 1, 2, 3, 4, 5, 6 times that I landed on heads. And then tails would be the rest. So that would be 14. And we're going to write our answer as the number of heads out of 20 and the number of tails out of 20. And so that would be this right here. And you'd want to go ahead and simplify that. So for heads, that would simplify down to 3 out of 10. And for tails, that would simplify down to 7 out of 10. Okay, so another vocabulary word is experimental probability. Experimental probability is when you run an experiment and you just write down the ratio of the number of times something occurs to the total number of trials. This would be just like that example that we just did, the heads and tails. That would be considered an experimental probability because those were the results that we got when we ran the experiment. Now, theoretical probability, on the other hand, is what is expected to happen. So it's an expected probability based upon the knowledge of the situation. To discover this, you're going to take the number of outcomes in event E. So the way I say this is the numerator is what you want to happen. Divided by the total. So in our previous example, the theoretical probability of flipping heads would be 1 out of 2 because there are one side that has heads out of 2 sides of the coin. Now this would be our theoretical probability of flipping heads, but then the same probability would be in place if we are flipping tails. We still have one side of the coin that's tails out of a total of 2. Okay, if we were in class, we would go ahead and combine all of our data into one. And what you'll notice is that when you start to put your data together, the larger your data becomes, the more closer it gets to the theoretical probability. Okay, so this is what I just mentioned. Your theoretical probability and your experimental probability should become closer together. So if we put all of our data together from the whole class of doing 20 coin flips, it should get closer and closer to 1 to 2. All right, so we're going to do another example, and we're going to calculate the population probability. To do that, again, we're doing what we want over the total. So if I'm trying to find the probability of living in Texas, I'm going to put how many people live in Texas out of, let's say we're trying to do the probability of the United States. So how many people live in Texas divided by the total number of people in the United States. All right, so here's the example that we're going to look at. There are 29 million people in Texas. Using the chart, what is the probability that a Texan lives in Fort Worth? So if we look at how many people live in Fort Worth, there's 932,116. So that's what you're going to put on the top, and then we're going to divide it by our total of 29 million. Now, if you type that into your calculator in alpha y equals, and then hit enter, it's going to give you the simplified fraction, which is this, and then just convert that to a decimal by going to math number 2, and then you'll get your decimal answer. Now, this is 0.0321, which represents about 3.21%. If I change that to a percent, that's what it would be. So it depends on whether or not they want it as just a decimal or a percent, so pay attention to how they want the answer given. If they're going to live in Dallas or Fort Worth, okay, so Dallas or Fort Worth, we're going to have to combine these two amounts. So the 1,382,270 and 932,116 comes out to be this amount right here. We're still dividing it by that total amount here, and this is what you get. Okay, which comes out to be 0.0798, and if we're going to write that as a percent, that would be 7.98%. And then let's find out the probability of living in the 4 most populated cities. And so you would have to add together the 4 most populated, which these are listed in greatest to least, so it'd be these 4 cities right here. If you add all of those amounts up, you get this amount right here. We're going to divide it by the total, and we get this amount right here, which would be about 21.7%. All right, you're going to do these problems in Moodle. So I have the Moodle assignment linked to the calendar. So make sure you get those done. This is going to be a formative grade.